When it comes to car maintenance, brake pads feel like one of those things you just replace without much thought. But when you dig into it, you realize there's a whole science behind what makes a good one.
Oh, absolutely. It's a classic case of what looks simple on the surface is incredibly complex underneath. The material a brake pad is made of fundamentally changes how your car stops, how much noise it makes, and even how dirty your wheels get.
Okay, so let's start there. When professionals evaluate brake pads, they first look at the material. I hear about ceramic, semi metallic, and organic pads. What's the real difference?
It's all about trade offs. Ceramic pads are the quiet, clean ones, perfect for most daily driving, but they don't have that super aggressive bite. Semi metallic pads with metal fibers in them are fantastic for performance driving or heavy trucks because they handle heat so well, but the trade off is more noise and they can be tougher on your rotors.
I see. And what about the organic ones?
Organic pads are generally softer, quieter, and more affordable, which sounds great, but they wear out faster and can suffer from what's called brake fade at high temperatures, where they lose stopping power. Then there's a middle ground, low metallic pads, which try to balance better heat handling with noise and dust.
That makes sense. So it's not just about what they're made of, but how they're made. What's the aha moment for a pro? What are they looking for beyond just ceramic or metallic?
You've hit on the key point. A professional looks at the entire formula, the binders and fillers holding it all together. The real secret is the consistency of the mixture. They scrutinize it for things like porosity, which are tiny air bubbles. Even microscopic pores in the pad material can create weak spots and lead to inconsistent braking, especially under pressure. A top-tier pad is incredibly dense and uniform.
Got it. So the material provides the foundation, but how do you actually measure if that material is performing well out on the road?
That's where the data comes in. Professionals don't just guess, they measure key performance metrics. The most critical one is the friction coefficient. They need to know if that friction level stays stable, whether it's hot, cold, wet, or dry. You want your brakes to feel the same every single time.
And I assume they test for that brake fade you mentioned?
Exactly. They simulate intense braking situations to test for temperature resistance. A great pad has to maintain its grip without fading. They also run tests that simulate thousands of stops to measure the wear rate and predict how long the pad will last and how it will affect the rotor. And finally, they measure noise, vibration, and harshness, or NVH, because nobody wants squealing brakes.
Right. So it's not just about stopping power, it's about predictable, durable, and quiet performance. So we have the materials and the metrics. What does the actual testing process look like?
It's a multi-stage process. It starts in the lab with specialized machines called dynamometers that can precisely measure friction and wear under controlled conditions, often following industry standards like SAE J600 and 61. This gives them hard data.
So it's not just road tests?
The lab is just the first step. After that comes real-world vehicle testing on test tracks to see how the pads actually feel and perform in a car, measuring things like stopping distance and pedal feel. They also meticulously check the dimensional accuracy to make sure the pad fits perfectly in the caliper, which is crucial for preventing noise and uneven wear.
That's incredibly thorough. It seems like a combination of pure science and practical application.
It has to be. They even test for corrosion resistance and look for certifications like ISO 9001 or ECE R90, which prove the manufacturer follows strict quality control processes. It's this combination of material science, performance data, and rigorous testing that ensures a brake pad is truly safe and reliable.
It's fascinating how much goes into it. It really highlights that evaluating brake pad quality is about so much more than a visual inspection.
Exactly. To sum it all up, it really boils down to a few core principles. First, understanding the material, be it ceramic, semi-metallic, or organic, and its inherent trade-offs. Second, focusing on key performance metrics like friction stability, heat resistance, and low NVH. And finally, verifying quality through a combination of rigorous lab and vehicle testing, dimensional checks, and trusting brands that adhere to recognized industry standards.